Assalamualaikum and hi. My name is Hazri Azhar Shizi bin Azmira, metric number BEJ44103. So, I would like to thank to Dr. Muhammad Razali bin Tumari as our coordinator. So, for the assignment 1, the given task is we need to do using HEP or perceptron and Adeline training algorithm construct classifier to solve the linear problem below. So this is the linear problem, S1, S2, S3, and this is for the class A and this is for the class B. So we need to, for the task given, we need to do two methods, which is perceptron, and the second one is Adeline. And next we need to retrain the data using perceptron and also Adeline algorithm. So alright, for this one, so what is Hebbian algorithm? So the step to do Hebbian algorithm, there are four steps, which is the firstly we need to know the random initial weight, and the second one is y equal to t, and the third one is w nu equal to w all plus n si plus times with y, and for the bn equal to bo plus n times y. For the for this task, we assume that the learning rate is equal to 0.5. So as you can see here, the first is to the random initial rate. So for the W1 is equal to 0, W2 is equal to 0, and also W3 is equal to 0. For the B is equal to -2. So this is the table that we construct, which is T is the target that we stated, and for the y is equal to the T, so it just follow the target. And for the W, as we stated before, Wn is equal to wo plus n times x times y. So we'll get for this W1 0, 0, 0, 0.5, 1, and lastly 1.5. And for the W2 0, 0, 0, 0, 0.5, 1, and lastly 1. For the W3 0, 0, 0, 0, 0.5, 0.5, and lastly 1. For the B, -2, -2, -2, -2, -1.5, -1, and lastly -0.5. So for the theta, we assume that theta is equal to 1, and also for the sum, which is x1 times wy plus x2 times w2 plus x3 times w3 plus b. So this is the answer for sum, which is negative 0.5, 0.5, 0.5, 3, 2, 2. So we get 2 1.5 x1 plus x2 plus x3 minus 0.5 is bigger or same as 1. So for the second one, 1.5 x1 plus x2 plus x3 minus 0.5 is equal to 1. So alright, for the task 2, we need to retrain the data. So so this is the table. As we can see here, this is the table that the data we have manipulated or retrained, which is for the x1, the target also change 111,000, and for the as we can see here, for the top of the table, x1 is equal to 1, x2 0, x3 1, and for the bottom 0 0 0. It also not same as the previous table. So alright, so we just do the follow the 4 step, which is and for the answer for the W1, we will get the last iteration 1.511 negative 0.5. We just do the follow the same step, which is how to find the W, how to find the B. Alright, so for the retrain data, we will get is after sum 1.5 x1 plus x2 plus x3 minus 0.5 is bigger or equal with 1. 1.5 x1 plus x2 plus x3 minus 0.5 equal to 1. So for we move to the second algorithm technique, which is Adeline algorithm. So for the Adeline algorithm, how to find the answer for Adeline algorithm, which is we need to follow there are 4 steps, which is first we need to initialize random initial weight, then compute sum, and then we need to calculate the W new, which is this is formula for W new, WO plus N times X times T minus sum. For the B new, which is this is formula for the B new, and the learning rate is 0.5. So this is the table show that for Adeline algorithm, which is firstly the random initial weight is W1 equal to 0, W2 equal to 0, W3 equal to 0, and B equal to negative 2. So T means target. So the target for this table is 0,0,0,1,1,1. So T minus with the sum 0 minus negative 2 equal to 2, 0 minus negative 1 equal to 1, and so on. So we will get here for the W, we will get 0.375, 0.75, 0.625, 0.125 for the B. So the net is we have to find for for the y. So this is the table. Get after the table above, we will get this table. So for the target 0.00111, and for the y 0.125, 0.85875, 0.75, 1.875, 1.25, 1.125 for the class A and B. And lastly, sorry, for the theta, we assume that is equal to 0.5, and this is the range, which is 0.125 is smaller than theta, and theta is smaller or same with 1.125. So alright, next we retrain the data, and we manipulate this, this is already changed with the data, previous data. So we just follow, or we do regarding the fourth step to do Adeline algorithm process. So for the W1, we will get 0.75, 0.125, 1, negative 0.0625. Oh, sorry. So after we do the step above, we notice that we will get this table, which is for the S we will get 1.6875, the second one is 0.8125, followed by 1.8125, and next is 0.9375, 0.0625, negative 0.0625, and we will get 0.75 x1 plus 0.125 x2 plus x3 plus 0.0625 is equal to 0.4375. So that's all from me for the simulation. My friends will show you with the detail. So that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asif bin Muhammad Anwar, with my metric number is BE41803. So let me introduce you of my part, that is Hebbian coding using the MATLAB simulation R2016A. So why I used the MATLAB? Because we need to visualize the decision boundary plot for each part in 3D data scatter plot. This mean we got three input here, that are x1, x2, and x3, and this is the data for x1, this is the data for x2, and the third one is the data of x3. So here, as you can see, the data that I have put here, actually this is for the x1, where this is for x2, and this is for x3. If you can see here, this is same as the data plot here. Then our target, I use 0, 0, 0 and 1, 1, 1 for the target, where the weight of our randomized weight is 0, 0, 0, and bias is -2, and the last one is the learning rate, and equal to 0.5. Here, the WJ means this is the formula for weight. As you know, the formula of weight is W alt plus the learning rate times to the target and times to the x. This is for our formula, and the bias formula is B bias equal to B alt plus N for learning rate times TI, that is for target. And this is my command for ensure that we got the final weight matrix and also for the final base values. Then the plot tree x1, 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 1, x2, 1, x3, 1, and so on are used to ensure that we plot the scatter plot graph. And this is for x label 1 is for x1, the y label is x2, while the z label is x3. And grids on, actually it is for our base use. It's easier to look for our graph, and the important one is about this, where we are needed to get this in order to get our decision boundary. So let me show the simulation and change folder. Okay, so this is our result from our command. So let's take a look for our Hebbian coding plot, where we got this sample, we got this output, where we can see the decision boundary placed at the middle of the sample, where the blue one, we consider it as 1, and the red one is for 0. As you can see here, the command 001 actually is for command for the color code. And that's all for the Hebbian part. Thank you. Okay, let us proceed with the next one, where we are needed in the assignment to retrain the data using HEP or perceptron and the Adeline algorithm using different training sequence. So here we are given the option for our training sequence that is from bottom row to top row. So we just use this training sequence, where from bottom row to top row we can see it by this sample, where the x1 we just put the top row before to the list row, bottom to top, to the bottom. So this is for x1 and x2, and the last one is x3, where our target also we put the training sequence from bottom to top, top to bottom, bottom to top, sorry. And this is our target. And this is our weight, and the weight is just the same as the previous one, is 0.000, and also for the bias part and the learning rate 0.5. As we can see, we just use the same formula for weight on Hebbian mode, whether it is from bottom to top or top to bottom. Also in the bias part, using the same formula, and overall the formula also same, including here. As we can see, the formula here just same as the previous Hebbian, the top to bottom sequence. So just let us look to the simulation, where we can see here it is almost the same with the previous one, where we can see the boundary located on the middle of the samples. So that's for Hebbian part of pre-trained sequence. Thank you. Assalamualaikum warahmatullahi. Okay, I will proceed for the next part is for Adeline, and here, as we can see, the command here, actually it is more likely for the previous one is Hebbian, but we change a little bit of command that is needed to in order to plot the Adeline part. So here, as you can see here, it is same as the previous one from this to the learning rate 0.5, but we have to put the ERR equal to 2, then the DW1 equal to 0, DW2 equal to 0, and DW3 equal to 0. Next, for the next one is DB equal to 0 and epoch equal to 0. And the while command for the ERR here, if ERR greater than 1.05 and ERR equal to 0, and this is the command in order to get the Y in. As we can see in adding part, we are needed to get the Y prime is equal to the summation, the T minus the summation, and this is for the Y in. And this is the usual one for weight of formula, where we can see here the change in the formula is at here, where we need to learning rate times to the summation, the target minus the summation, that is P I minus the Y in I, and we need to times with the X whole. Then also in the bias part, where the B all plus the learning rate times with the subtraction of target minus the summation, and we need to print x1i here is just the basic command in order to get the result. And epoch equal to epoch plus 1 proceeded by plot 3, where we are plotting the data of our command to get the scatter plot, where we can see here this is the different command with the third row from below, where this is for the color code in our scatter plot, and x label is for x1, y label is for x2, and z label is for the x3 proceeded by grid on. And in the adeline part, we are using the different linear equation, where it is the common part where we will got the difference of equation with the Hebbian part, because we are using the adeline. And this is for y in equal to p plus x1i times weight of 1 plus x2i times the weight of 2, and x31 times weight of 3. And here let's see the result. And for the adeline part, I got this value. As we can see, this is the decision boundary for the adeline part. And that's all for the adeline part. Thank you. Okay, so for the next one is adeline in retrain sequence algorithm, where we use the training sequence of bottom to row, where we put the 11100011010101100. This is for x1, x2, and x3. And for the target is 111000. For the weight is 000. Bias is -2, and the learning rate is 0.5. And our command just same as the previous adeline part, because we just need to change a little bit of our finding, where the most important thing is here, where we found out that the equation here was different with the previous adeline part, that is top to bottom. So let's take a look to the simulation, and shockingly, we got this kind of output, 3D output. So that's all for adeline's retrain part, the bottom to top sequence. Thank you.